This is the last part in this chapter. Already you know it, and already we saw the asymptote, but just wanna little bit, uh, like I say, summarize it. So I can see the asymptote graphically by I can have together one vertical, one horizontal, and I can have together one vertical, one oblique asymptote. The oblique asymptote we'll see it later. I'm gonna give it to you as an extra part, and it's not under your book, but it's better to give it to you now. You're gonna see it later, and also grade 12, you're gonna see it at the university. Okay. So if I look at the first graph, okay, when you see vertical line, this one is called the vertical asymptote. Okay, so I can see that x equal 1 is vertical asymptote, and y equal -3 is a horizontal asymptote. If I look at the second graph, all the time you label vertical asymptote by VA, horizontal HA. I have here a vertical asymptote is x equal 2. And this one, like this, when it's a normal line y equal mx plus b, it's called the oblique asymptote, okay? OA, oblique asymptote. We will see it later. We're gonna do some exercises together. Okay, so graphically I can see it like this. I see a vertical line, I see a horizontal line, I see an oblique line. You need to be careful. I cannot have horizontal and oblique in the same time. I will tell you why later. Okay, let's continue now. Now by calculation, how I will find this? If I have limit of f of x when x tends to infinity gives me a number, and when x tends to infinity gives me another number, in this case I have horizontal asymptote. So if it doesn't give me a number, it gives me infinity, infinity. Here I have a possibility of an oblique asymptote. That's why I told you I cannot have it together, because I cannot have in the same time limit of f when x tends to infinity a or and infinity at the same time. So or it's a number or it's infinity. So when the limit of f of x when x tends to infinity gives me a number, this is the answer is y. So y equal to this number is a horizontal asymptote. When it's infinity, I'm not sure there is an oblique. I need to write possibility of an oblique asymptote. And I will show you later how to prove it. Okay? I will write just possibility of an oblique asymptote. Now, if I have the limit of f of x when x tends to b, to a number, b plus or b minus, and it gives me infinity, in this case, x equal to b is a vertical asymptote. How do we prove oblique asymptote? The question will be given, show that, for example, I will tell you, show that y is equal x plus 1 is an oblique asymptote. In this case, how are we going to do it? We're going to write, how do we prove? We prove it like this. Limit of f of x minus y, minus the oblique asymptote here, when x tends to plus infinity, and you're going to do it also when x tends to minus infinity, my answer should be 0. Leave it for the moment here, because I will do it later, because I thought this is not in your book. I'm going to do it later as an extra part. There's still a small part in the book, but not really deep, okay? So like this, we prove oblique asymptote. And if I got 0, I can deduce directly that y equal x plus 1 is an oblique asymptote. I will give you this with an exercise later. Then the last part in this chapter, هي continuity at a point. How do we prove that a function is continuous? What does it mean continuous at a point? يعني there is no discontinuity. It continues. يعني at 2, I continue like this and this. For example, if it was like this, I can have like this and then like this. Sorry. If I have a point. If it was like this, it's not continuous, okay? So what does mean continuous? It means I can join those points together. It means at 2 and little bit before 2 and after 2, there is the same value, okay? So how do we prove that a function is continuous at a point? I need to do the limit of f of x and x tend to a plus. And here, for example, 2 plus, little bit before, after. And the limit when x tend to 2 minus, it should be both equal to f of 2. Okay, in this case, I should have limit of f of x when x tend to 2 plus. It's the same as limit of f of x when x tend to 2 minus. It's the same as f of 2. Also, we're going to do application for this one. Just memorize the formula. Just memorize now for the moment this one. And also we will do it in an exercise, okay? That's it. This is an example. Look at it. How nice. Study the continuity of f of x at 2. I have the function. It's given two parts. X plus 2 if x less or equal than 2. And minus x plus 6 if x is bigger than 2. There. I will start to calculate f of 2. Where is f of 2? 2 belongs to this part or this part? Here, because it's equal to 2. So I will replace it by 2. 2 plus 2 gives me 4. Then I will do f of x, limit of f of x when x tends to 2 plus. 2 plus, it means bigger than 2. Where is bigger than 2? Here or here? Here it's bigger than 2. I replace x by 2. I have minus 2 plus 6. The answer is 4. And limit of f of x when x tends to 2 minus. Where is 2 minus? Here. I will replace here, my answer is 4. What does it mean? It means that at the point 2 and before 2 and after 2, the point they have y equal to 4. It means it's continuous. The y exists and it's equal to 4. So what can I deduce? That it's continuous. Okay, we'll do more application, more exercises about the continuity. Okay, that's it. This is all.